Okay, so next up we're going to talk about web performance and why web performance is important and what you can do on your websites to make your own sites work a bit faster and a bit better. So firstly, web performance is really important. So Amazon did a test where they dropped their page speed by about a second, and for Amazon that resulted in a 7% drop in sales for that test period, which is a huge amount of money. If you're Amazon, that's a very huge amount of money. In any website though, 7% drop in sales is significant. So it matters in terms of sales and the conversion of what it is you're doing on your website. It doesn't have to be sales, it can be conversion of people signing up to an event, it can be conversion of people downloading something. Whatever your kind of conversion parameters are, web performance will affect how many conversions you get. It matters in terms of visitor retention. So there's a study of UK online shoppers where 40% of them abandon the website if it takes more than 2 seconds to load. So imagine they go to their favourite search engine, they do a search, they click a link, and if the site hasn't loaded and is usable in 2 seconds, they'll click the back button and go back to the search results. 40% of them will do that. And the longer the site takes to load and be usable, the more likely they are to click back to the search results. So it matters in terms of visitor retention and people bouncing off your site as soon as they've hit it. It also matters in terms of SEO. So Matt Cutts is one of Google's more prominent SEO people, and he's been on record to say that Google is incorporating site speed, which is what Google's phrase for performance, as one of the over 200 signals used to determine search ranking. So Google thinks performance is important enough to potentially penalise sites that are performing slowly in terms of search results. And of course, all the other search engines will do the same thing here as well. So it matters in terms of SEO and search optimization. So performance matters. It matters for conversions, it matters for visitor retention, it matters for SEO. It matters for lots of reasons, not least making your visitors' experience on your website a good one. So I'm going to talk about a few things here. I'm going to talk about what the strategy is for addressing performance. How can you actually start to look at your website's performance and figure out what's going on. We'll look at some tools and techniques for actually analysing your site and working out what the specific weak areas are. And they'll boil down to two main categories of recommendations. One in terms of reducing the amount of requests that your site has to do, and the other one in terms of optimizing the amount of requests that are left over. So tuning strategy, how do we actually address this? What do we look at first when we're trying to optimize our websites? It's very simple. You focus on the front end. So this diagram here shows a network request for one of the UK's major retail websites, and the blue box is what happens on the front end. So this is work. Front end means work that the browser has to do. Individual requests, each one of these lines is an individual request that the browser has to do to download some resource that's needed to render the site. Mainly it's images, it's JavaScript files, it's CSS font files, those kinds of things. But you can see in this case, the browser has to do a lot of work, has to download lots of things in order to render the website. The pink box at the top is the back end. So this is what happens on the server, and this is the time it takes the server to respond with the initial HTML page. So the guidance here is roughly 87% of traffic or page speed happens on the front end. So if you can optimize your front end, you're going to be in a very good place. Focus on the front end first. The back end is still important. That still accounts for sort of 13% in this example, but it's nowhere near as important as the front end. You can do all the back end optimization you like. If your front end isn't properly optimized, it won't count for anything in terms of actual performance of your website. So front end performance is first, what the browser has to do in order to render the website. So the first thing you need to do is understand what's going on your site. Try and get a feel for what the issues are, what your site's doing well and what your site's not doing well. And there's some really good tools to help you with this. So there's a tool called the Web Dev Checklist. This is a tool written by a guy called Mads Christensen, who is a Microsoft engineer. He's done a lot of work around tooling with Visual Studio. He's one of the main guys involved in the Web Essentials tooling that you might have seen for Visual Studio. And he's got this website called Web Dev Checklist. And what this is, it's literally a website you can go to, and it gives you it's a checklist effectively for good web practices. Some of it's performance related, some of it's just generally good web practices. There's a section on ASP.NET. At the moment it's 4.5, but hopefully that'll be upgraded to core at some point soon. And it's also available as a browser extension as well. So that's a good one to go to. Yahoo YSlow is a really good one. That's what's shown in this screenshot here. So Yahoo have long maintained a rule set for what makes good web performance. They seem to have had it ever since the web's been around, really. And there's a plugin that will allow you to analyze your site against their rule set, and it will give you indications as to where the site could do better and where the site's doing well. It gives you scores and grades and that kind of thing. Google also have a very similar tool called PageSpeed Insights, which is available. It used to be a browser plugin, but it's not anymore. It's just a URL. And it does the same kind of thing. It scans the site and it will assess how well it complies with Google's rule sets around what makes a good website. So there's a couple of tools that you can look at there to help you understand your issues. So let's take a look at some of these tools now and see them in action. So I'm going to start with a website. Normally, if I'm doing this live, I would ask the audience to volunteer a website. But that might be quite difficult to do. So I'm going to use our UK developer site. So this is microsoft.com/ENGB/developers. Or if you just search for Microsoft UK developers, you'll find this site. So this is a subsite of Microsoft.com. It's what we use to sort of collate all of the stuff that goes on in the UK developer community in the UK. Some of it comes from people like myself. Some of it comes from third-party Microsoft Value professionals, those kind of things. Some of it comes from our editorial team. But it's basically a site that we use just as a landing page for UK developers. So I'm using Chrome here because all the extensions that are used are available here as Chrome add-ins. And I'll start with trying to go to the web dev checklist. So if I just search for web dev checklist add-in, there it is, it's in the Chrome Web Store. And I can just add to Chrome. It's saying yes, add an extension. So Firefox will work in the same way. Hopefully these will be on Edge soon. Extensions are coming to Edge, but we don't have them just yet. So that's now been added. And whilst we're here, we'll also add the YSlow as well. So here's the YSlow one for Chrome as well. So I've got these two extensions installed now. So firstly, I'm just going to quickly go to the Web Dev Checklist website so you can see what that looks like. This is it. It's literally a checklist of things, and it gives you some really good details about how to implement recommendations. So here it's saying make sure the spelling's there, and there's some tips for that. There's loads of stuff on performance here. Yahoo YSlow, Google PageSpeed, and then you've got the nice menu where you can have a look at performance, specifically on ASP.NET in this case, and just work through this checklist. So that's a really good one to use. So what I'm going to do now is I'm going to go to our website here, and I'm going to scan it using the YSlow extension that we just installed. I'm going to do run test, and this is going to now scan the website, and it's going to assess the website against our own what Yahoo's rule set to see how well it complies, and where it's good and where it's not good. Okay, so that's now up and running now. We're going to look at the results. So we can see that this website scored a grade of C with an overall performance score of 79. So it's certainly not the worst website in the world, but it's certainly not the best either. And there's a load of stuff here about things that we can do better. So one of the first things it's recommended is to make fewer HTTP requests. So it's saying that this page has 7 JavaScript files, 7 style sheets, and 7 external background images. So those things could be merged together potentially. So that could be one JavaScript file rather than 7. It's recommending here that we use a content delivery network. So it's saying there are 43 static components that are not on a CDN. Now CDNs are something that's not necessarily good advice for everybody, but it's certainly something to consider. And actually that goes for all of this. So not every time the advice is going to work for your particular website, but it's certainly things to consider. Expires headers is a really key one. So this is saying that there are 7 static components without a far future expiration header. Now, an expiration header is a tag that you can put onto the file itself, which means that browsers can cache it. So it says that this file expires at some point in the future. And if those are there, the browser can cache it rather than re-requesting it every time. So it's saying there's 7 components here, where some of them do have expiration dates, they're not in the far future. So some of them expire today, some of them don't have expiration dates at all. So that's something we can do. It's saying that we can minify JavaScript and CSS. There are components here that are not minified, and there's some inline script that should be minified. That just reduces space on the wire. E-tags is another important thing. So this is where, again, it's to do with the server caching, the ability for the browser to cache the file. And then finally, we've got cookie-free domains, which basically means there are components that are on the main domain of the website rather than a cookie-free subdomain, which means that cookies get sent when they don't need to. So it's simple stuff, but useful stuff. So we've got an overall score of 79% with a grade of C. If we look at the components tab, we can actually see what all those JavaScript files are. So it said there were 7 JavaScript files, and here they all are. Here are the 7 files that are responsible. So we can see the size, we can see where they're stored, what the expiration headers are, that kind of thing. We can also look at the same for CSS. These are all the CSS files that are needed to render this page, and so on and so on. Now, the really interesting one, and we can see here there's 54 components weighing over 1,700 bytes of data, which is quite a lot. So if we go to statistics, this is where it gets really interesting. So this is where we've got the empty cache and the prime cache. Empty cache is when you first visit a page. So we can see that on the empty cache, this has needed 54 requests with 1,700 K of data. We can see the 22 images, 7 CSS images, 7 style sheets, a favorite icon, etc., etc. Now, the prime cache over on the right is really where the performance gains can be had. This is basically the refresh, the F5. So even on refresh, we're still making 8 requests and we're still downloading 48K of data. Now, really, on a prime cache, if it's optimized, that should be more like 1 or 2 requests. So every single time you navigate a page on this site, the browser's having to download 8 things in order to render the page. And that's why it's scoring not so great on the performance scores itself. So that's a part of Microsoft.com. You would expect that to be a well-designed site. So you might be thinking, well, how can we do this? Is this even possible? And it is impossible. So I'm going to go to my own site. This is a site that I've got, which lists all of my resources, so my blog articles, my links, my speaking information, that kind of thing. And I'm going to use YSlow to analyze this as well, just to see how well this passes the test. So this is an ASP.NET Core website running on Azure. Now, this is not 99 by any stretch of imagination, but it's a grade A, it's 94. So it's saying that I should use a content delivery network. Well, fair enough. But I'm using things like Google APIs. That actually is a CDN, as is ASP.NET CDN. So I can add those as CDNs. But it's saying there's certain components that are downloaded from my domain, which isn't a CDN, so that's fair enough. There's certain things that aren't using expires headers, but they're things that are out of my control. So Google Fonts and Google Analytics. Same with entity tags, same thing. I'm using a CDN there, so those aren't configured with entity tags, out of my control. And cookie-free domains. This is something that I could address if I wanted to, but it's just not worth it for this kind of site. But I can see that all the other stuff is passing to give me that score of 93%. I can see these are all my components, and I can look at statistics, and I can see that the initial page is 14 requests, which is fairly decent, but the cache page, the prime cache, is only 3 requests. So it downloads the HTML document from the server, a JavaScript file, and a style sheet, and that's it. Which means that it's a very, very lightweight site, especially when you're browsing after the first request. Now, just to complete the picture, let's have a quick look at the Google PageSpeed Insights and see how the sites perform on that. So this is the page. I'll take a URL for our Microsoft.com and pop that in there as well. So this is a very similar thing. It analyzes against Google's rule set now rather than Yahoo's, and it gives us a score. So Generally speaking, the Google Developer Insights will be a bit harsher than the Yahoo one. They seem to be more picky, which is a good thing, I guess, because it gives you more things to try and fix. So we've scored 47 out of 100 here for mobile, and it separates it out as desktop, so 60 out of 100 for desktop. So in both cases, not great. So there's some stuff here, things you could fix. We've got render blocking JavaScript above the fold. So this means that there's things that happen on this first page with JavaScript that needs to render in order for that to be shown. Server response time is quite slow. Now, this is saying that it's 3 seconds. So that may be true. That goes back to that 2-second rule. If a site hasn't loaded in 2 seconds, people bounce back. And it's also saying that images that aren't optimized here. So it's saying there's some images that could be compressed and optimized. We can see there's 42% could be saved, 44%, etc., etc., 50% in some of these cases. And we'll talk about how to do some of this stuff in a second. It's also saying we should consider fixing browser caching. Again, this is the expiry headers, compression, minify JavaScript. And then on the desktop, it's a similar set of results. So you can work through this just like you can do with the Yahoo rule set and try and analyze your site and figure out what's wrong. So those are the tools that are available. There are other tools, but these are the 3 that I use: the Web Dev Checklist, the Yahoo Why Slow, and the Google PageSpeed Insights. If you can get into the top 90s on Yahoo and Google, you're in a really good place and your site's going to perform really well. So those are the tools that are available for us. And those tools really boil down to 2 main things that you should do. The first one being reduce the number of requests. So this is this idea of taking all of those requests and making them fewer. So try and eliminate unnecessary requests that the browser has to make. So we remember that first page where we had that big long list of 50 odd requests for that retail website. Try and reduce those where we can. There's ways you can do that. The first thing, and just before we go into the details here, in terms of ASP.NET, there are some differences in terms of tooling or how you do this. So if you're using ASP.NET 4.6, broadly speaking, you can implement most of this stuff using Web Essentials, which is a Visual Studio extension, and changes to the web config. Because in 4.6 we're relying on it being a Windows server, it means that you can use web config and you can make Windows IIS changes via web config. In .NET Core, it's a bit different because we can't assume it's a Windows server, so we can't really use web config so much. So we're using changes in startup.cs and we're using ASP.NET middleware. And we're also generally using either Gulp or Grunt plugins to implement a lot of the stuff that Web Essentials does. So it changes in implementation, but the basic idea is the same. So the first thing it will ask you to do, first thing you should look at doing is bundle your files. So take files that are the same type and make them a single file. So in this scenario here, let's say we've got 3 JavaScript files. We can use Gulp Concat, which is a Gulp plugin, to make a single JavaScript file. So that's 1 request. 3 requests become 1 request. So combine multiple files into one. You can use Gulp with Gulp Concat to do that in Gulp, or you can use the bundling and minifying extension for Visual Studio if you've got ASP.NET 4.6. So bundle your files where possible. You can do this with JavaScript and with CSS. Secondly, enable browser caching. This is one of the main things you can do. So this is that expires headers, and it enables the browser to cache files without having to download them each time. So set far future expiration headers. Generally speaking, they'll need to be 7 days in the future. Doesn't always have to be that case, but to pass the test, they generally need to be 7 days in the future. You can do this if you're on Windows. If you're running on Windows, you can do this by just enabling client cache in web config. Or if you're using ASP.NET Core, you do it in the startup using the static files. But in either case, have a cache busting strategy. Have a way to break through this cache. There's lots of ways to do this. In ASP.NET, you can use the tag helpers, the link tag helpers to do that. Have a search for cache busting strategy online and you'll find lots of ways to do this. Another recommendation, I think, it's not going to be picked up in the tools, but I like to use fonts for icons rather than using images. Fonts are lightweight and scalable. They're a single request, or certainly a small number of requests. And they're HD by default, so they'll scale on Retina displays, on Surface Pro displays, that kind of thing. Font Awesome is the one I tend to use the most. It has lots of icons and it's all delivered through CSS and fonts. Now there is an argument to say you should be using SVG, and it's a valid point. Personally, I think the workflow to generate SVGs kind of counterbalances the benefit. So from a developer workflow process, it's an overhead, whereas using something like Font Autumn isn't really an overhead. If you're talking about pure performance, yes, SVGs in most cases will give you even better performance than fonts. But the point here is do something other than images. So it doesn't matter so much if it's fonts or SVG. Just make sure you're not using lots of images for your icons, and you'll be in a good place for performance. So the next thing we do, once we've reduced the number of requests as much as we can, is we try and optimize the ones that are left over. So this is trying to make those remaining requests as small and as efficient as possible. There's a few ways we can do this. First, we compress text files. So if you're on webconfig, you can enable dynamic and static compression in webconfig, or you can use Gulp gzip. So the idea here is on the server, we compress text files before they go out. So as well as minifying them, we compress our CSS, we compress our HTML documents to make the actual file as small as it can possibly be. We minify. So this is the process of taking out comments, white space, shortening variables, making your JavaScript and CSS files as small as they can possibly be. So a browser doesn't need a JavaScript file to be well formatted and easily readable in order for it to work. Same with CSS. Humans do. So when we're developing our files, we need them to be readable. They don't need to be readable for the browser. So the act of minification saves quite a lot of space. Now you can do this using the bundling and minifying extension in Visual Studio. You can also use Gulp Minify CSS if you're using Gulp, and you can also use something called Gulp Uglify if you use for JavaScript. So there's tools to help you do this, and it's something that you should just embed in part of your developer workflow. Another key thing to do is around images. Images are, generally speaking, the biggest block of data on any website. You can use the image optimization Visual Studio extension, which will just let you right-click an image and optimize it. And this doesn't optimize it in terms of make it smaller. It simply removes the unnecessary data in the image file itself. So you can do a lossless optimization, so the quality won't be affected, the size of the image won't be affected. It'll just have a smaller file, which is the key thing there. You can use a Gulp package called Gulp ImageMin to do the same kind of thing. And the other key thing here is to serve files at the right size. Don't serve files and then don't serve large files from your server and then scale them down in the browser. So if you're serving something at say 200 by 200, that's what the image should be as well. Don't serve a 400 by 400 and then have the browser scale it down. There's two things that happen when you do that. One, you're sending twice as much data over the wire than you need to. And two, you're asking the browser to do some graphical processing work in order to render the image. It's actually browsers are quite inefficient at doing that. So definitely serve images at the right size. And if that means you have to have multiple copies of your image, then that's the way to do it. If you look on my website, martink.me, you'll find some resources about smart thumbnail generation using cognitive services. So have a look at that as an API that can help you with this, do this in a smart way. But definitely serve images at the right size and try and optimize them as much as you can. JavaScript's a key one. So JavaScript is on most websites and it should be at the bottom of your website. You should move it to the bottom at the very least. And if you can, you should run it asynchronously or even defer execution. So the reason for this is because it allows the DOM to load first. It allows the kind of HTML to load in the browser first, and then it loads the JavaScript. Google use the phrase render blocking JavaScript, which is so it blocks the render of the page. If it's at the bottom, it doesn't do that, especially if it's deferred or if it's asynchronous. So use defer and async if you can. If you can't, just make sure it's at the bottom of the page. So another thing you can do is you can bring data closer to the users with CDNs, content delivery networks. This is only really relevant if it's an international website, so if you're going across borders or you're multi-region at least. If you're just a site that works just in one city or region or even one country, this might not be so relevant. But the idea here is of using fast cache storage. So rather than users dragging static files from your web server halfway across the world, they'll get them from a local CDN. There's two benefits. One, CDNs are generally faster at serving files than web servers are. Two, it's local to where they are. It doesn't have to be downloaded halfway across the world. We've got some options in the Azure for this. So you can use Azure Storage to store your files, and you can attach that to Azure CDN to distribute them geographically. So we've covered a lot of stuff there. So we've looked at strategy, the idea of optimize for the front end first, generally speaking, 87% of performance hit happens on the front end. Back end's important too, but front end's more important. We've looked at tools, so we've got the Yahoo Why Slow, we've got the Google Page Speeds, we've got the Web Dev Checklist, and probably lots of other tools as well. We've got the Gulp plugins, we've got the minifying extension for Visual Studio, we've got Web Essentials for Visual Studio. Lots of tools to help you with this. And broadly speaking, they're going to ask you to reduce the number of requests that you've got on your site, and then optimize the ones that are left over. And that's going to give you those high scores on the performance tools. So you can contact me. I've got lots of resources on this area on my website, martink.me. If you go to links, there's a whole section on web performance that you can look at there. You can tweet me, you can email me if you've got any questions about this. Thank you very much.